Hi, everybody. Thanks for joining us for episode 2 of Going Places. I'm Beth, and I'm here today with Alka.
Hi, my name is Alka Tripathy-Lang, and I study when rocks came to the surface of the Earth, which gives us information about how they get to the surface of the Earth. Rocks like this. This is an eclogite. I'm going to zoom way in. I hope you can see that it's green with a little bit of red. Those red dots are garnets, and garnets are these amazing container minerals that hold clues about how deep rocks like that particular eclogite went. So we are going to jump to the Himalaya, which is where India and Eurasia are currently colliding to form the highest mountains in the world. Mount Everest lives there, lots of other high peaks. So here's India, here's Eurasia. This arc here, this arc shape, that's the Himalayan range. There's this great video by Tanya Atwater at the University of California, Santa Barbara that shows how India and Asia collide. I want you to notice how deep the rocks of India go, and also how these rocks are thrusting themselves, shoving themselves up on top of India. If we go back to Google Earth, we can see evidence of those thrust faults in these linear features. You can see how you can see all these nice linear features. Those are all faults. Some of them are thrust faults. This one right here is a strike slip fault. There's different types of faults that are going on here, but these are the boundaries that help get some of these interesting rocks to the surface. If we zoom in even more to this region, this is the Somorari area in Ladakh, which is in the northwestern part of India. This right here is Somorari. It's a high elevation lake. And the road up here that is how you get to Somorari, it parallels the Indus River. The Indus River goes through this package of dark colored rocks. These are ophiolites. It's called the Nidar ophiolite. You can actually drive through the entire package of ophiolite. An ophiolite is actually seafloor that has been shoved up on top of India in this case. And you can actually drive all the way from the pillow basalts that are erupted on the bottom of the seafloor all the way down through the upper crustal rocks here. But what's really neat is when you hit this boundary right here, that's another fault, you get into this peculiar terrain called the ultra high pressure metamorphic terrain that was only discovered in the last 20 years or so. It's all these light colored rocks that go from this dark, this boundary of dark to light, the ophiolite to not ophiolite, to over here where there's another boundary of darker colored rocks with lighter colored rocks on the other side. So this light colored package of rocks, it was actually taken down very, very deep. And it's really, really neat how geologists were able to figure that out. If we zoom in a little bit further, it's really hard to find these blobs of eclogites like that rock that I showed you at the beginning. Let's see if I can find you an eclogite blob here. So right here, so the rocks that we're looking for, they're right here, that little dark blob. We can switch to this great picture of what the eclogite actually looks like in the field. So this dark blob that looks like it's been smeared into these lighter colored rocks is the eclogite. It has garnets in it. And inside those garnets, inside those container minerals, are these other minerals called coesite. What's really neat about coesite is it's a polymorph of quartz. So it is quartz that has been smushed so that it no longer has the same structure as quartz that we have at the surface of the Earth. The only way that that can happen is if you take it really, really, really deep down into the surface of the Earth. It tells us that this particular rock was down about 100 kilometers depth and then somehow came back up to the surface of the Earth. To give you an idea of the scale of these rocks, there's me perched on one of these blobs of eclogite. You can see there's another blob of eclogite over here. There's a smaller one up above me. They're all over this area and they're really fascinating. And I just think it's really, really neat that these rocks went down super deep and they came back up to the surface of the Earth and now we can see them today. And that's it.
That's so amazing. Thanks, Alka, and thanks everybody for joining us today. See you next time.